Hey guys, welcome back to another DirectX engine tutorial. In the last video we created shaders. I know so far we haven't created stuff on the screen yet. I apologize, but we need to have all this stuff first before we initial. I can cheat it and just to show you guys something, but then I don't know. I just want to have all this stuff done already. We're not gonna use shaders yet that we did in the last tutorial because what we're gonna do now is gonna need the shader class, so that's why we did it first. So let's start that. We're gonna do let's start it. We can work on the vertex buffer stuff that will render our stuff on the screen. And so you want to add a class, of course. I'm gonna call it vertex buffer. I don't know. I don't really have a good name for it at the moment. I'm not that good at naming stuff, so okay. Pound sign. If in def. Underscore vertex buffer underscore h number define vertex buffer. Yeah, you guys have a better name for this class after we're done with this tutorial, then let me know. I can change it, or you guys can name it whatever you guys want. I don't. It's up to you guys. Anyway, this is your engine, your simple engine, I guess. Even though, yeah. Vertex buffer. We have that. Okay, so we can include a shader, which we did in the last tutorial. We're gonna include D3D11, the H, and want to include D3DX10 math H. Okay, so in here we can create a struct. Whatever. Call it vertex type. And in here we can have a D3DX vector 3 position. We can have a D3DX vector X vector 2 for the UVs. Now we have that. You're gonna create the functions. We'll initialize. We're gonna pass in the parameter of ID 3D11 device. We're gonna pass in the shader. A float size. And bool writable, in case you want to rewrite stuff on them. You want to update the vertices, like for animation. This is mostly for the animation one. We will need it. You need a size because for this vertex buffer we're gonna create a plane. It's nothing fancy. It's not creating anything else but a plane. You can update this to make it draw something else if you guys want after you're done. It's up to you guys, but for this tutorial, for this, what I'm gonna do is just gonna draw a plane. So that's what we're gonna do. And we can have render, pass in ID 3. I had a 3D11. Device context, pointer, device context. We're gonna have a vertex type. You're gonna get the vertices. ID 311 buffer pointer. I get vertex buffer, which is the reason why I didn't want to call this class vertex buffer, because what we're gonna do in here is called, well, I don't know. I'm mumbling stuff now. Okay, anyway. Continuing. Another function to get the index count. We really need an index count. Oh, we'll have it in there just in case we do need it someday. Private. We're gonna have private variables, ID 311. Buffer. Pointer. There's an Vertex buffer. Another one, ID 3D11 buffer for the index buffer. Vertex type, pointer, and that's gonna be the vertices. And the shader. So that's it for the header file for this. Alright, and like always, I went ahead and created the functions. Passed in here, make sure you call it 0 or null, whatever you guys want to call it. In the constructor and the destructor, make sure you delete it and release all the memory that needs to be released. So once you have that, you're going to go to initialize. You're going to have in here, yes. Now unsigned int, oh no, unsigned long, actually much better. Unsigned long pointer, and call that indices. D3D11 buffer description for the vertex buffer and the index buffer. Another one, D3 D11 sub resource data for vertex data and index data, and H result, like always, guys. Okay, you want to set a number of vertices since we know that this gonna be, I need it. I did not call it. Hold on. Go back to a header file. Forgot to add. I forgot to add the vertex count. Of course, we need it, and int m index count. Okay, once you have that, since we know that this is gonna be a plane, then you know that it's gonna have 4 vertices, and since it's a 4 index for us a plane, then we know the index is gonna be 6. We can have 6 indices that will determine determine that plane. I'm trying to figure out if I should show you a picture of it now or should I show it to you afterwards. You know what, I'll do it now. Let me open Paint. Sorry. I apologize, it's white. Hopefully it's not a big issue. So we have trying to figure out the axis in DirectX. Okay. In DirectX, the axis for the Y. Oh, hold on. That's not how I need to paint. For the Y, up will be positive. Oops. Sorry, I can draw an arrow. Up will be positive and down will be negative. So the way I define this, you know that the planes consist of 2 triangles. Of course, it's not a perfect triangle. I apologize. And the way I created this plane is that I created the first vertex down here, 0. This is the first vertex. This is, well, 0 vertex, first vertex, second vertex, and the third vertex, which will consist of 4 vertices. So the way that I'm creating this this plane is that indices will start here from this point. It will go to 1, and then we'll go to 2, and then it will go back to 3. I mean 0. So it just creates this triangle, and then to create the other triangle, I start from 0 to 2. I'll go back to 2, and it'll go back down to 1. I mean to 3. And then, like always, DirectX will magically draw this line for me, to which will create the triangle that we need. So we can start. I need a bigger brush. Hold on. How do you create a bigger brush? I really use paint here. What size? So we're gonna do start from 0, go up to 1, go to 2, and then go back to 0. And then once it does that, it'll go back. It'll start at 0, go back to 2, and it'll go to 3. And DirectX will do this line automatically for me, and we have a will turn to a cute little square. It will not be like that, so ignore that. So there you go. That's how we can create this plane. Hopefully you guys understood that. Hopefully I didn't confuse you guys. So let's start this. We can create a vertex. Vertex. I mean not vertex. Vertices equals new vertex type of vertices count, and our indices. Oh no, it's not. We're not keeping track of that. Equals new unsigned long of index counts. Then we can have a float half size. We can make this plane to be in the center, so when we want to rotate it, will rotate towards the center. So we can basically start off from here, and we can subtract half with half size. So negative half size. Negative, positive. So, like always, we can start here, right? It's negative half size and negative half size on the Y, which will start here. So that'll be the first vertex. So we're gonna load vertex array. So vertices 0. Dot position equals d3dx. Vector 3, negative half size, negative half size. And on vertices, I'm gonna create our UVs, 0 dot UV equals d3dx vector 2, and it's gonna be 0 and 1. What did I do? So like always, go back to here. These make sure this is Y. X is the same thing. X is negative that way. This is for X. Negative that way and positive that way. So we're gonna start from the center, since we want this plane to rotate from its center, and in order to do that, we're gonna create the vertices from the center point. So it's gonna be negative half size minus negative half size. Since Y is down, it's negative. So basically this is negative half size for X and Y. And since the UV starts from 0 from top, I should have created different color codes. Hold on. For this corner, it's gonna be that one. This corner is gonna be 1, 0. This corner is going to be 0, 1, and this corner is going to be 1 and 1. So there you go. That's what we're going to do this plane. It's going to start from 0, center point, negative half size, and negative half size, which will end up in this point. And then for the next point, it's going to be negative half size and half size, since positive is up. Yeah, I hope you guys got it, because I don't want to make this tutorial longer than it should be. If you guys are confused a little bit more, then let me know. So just negative half size and half size, and there's no Z on it. You're gonna create the UVs. Equals d3dx vector 2. And since the top one is 0 on both, for the second one, dot position equals d3dx 3. Okay, I was confused there. It's gonna be half size and half size, and of course the other one's gonna be 0. Vertices 2, the UV equals d3dx vector 2. Since it's the top right corner, it's gonna be 1 and 0. And for the last vertices, or vertice, or vertice, I don't know how to actually say a single one. d3dx, it's gonna be half size and negative half size. And of course the last one is 0. And for UBs, you guys can guess that one if you guys want. Equals d3dx vector 2, 1, and 1. So that's for the vertices that we can create. And now we want to load the vertices, the indices. And like I said earlier, the first triangle that we can create is going to start from 0, 1, and 2. I don't know, did I create it 2 here? I just got hit. 0, 1, and 2. So that's going to be our first triangle. We start from 0, 1, and 2. And our next 3 triangles is going to be 0, 2, 3. 0, 2, and 3. That's that. Now we want to set up the vertex buffer. Set up vertex buffer description. Okay. For the making a vertex buffer description. Yep, I'm gonna do it again. It's usage. This one's gonna be set up a little bit weird. We can check to see like if it's gonna be rewritable. And if it is going to be rewritable, we want to use the D3D11 usage underscore dynamic. Otherwise, if it's not rewritable, we want to set it to D3D11 usage default. For the byte width, and we can set the size of vertex type times the m vertex count. You can have bind flags. You can set that to D3D11 bind vertex buffer. I can CPU access flag. Oh, I already said it for me. How is that possible? Okay. Alright, not gonna complain. For this one, we also can use the rewritable. If it's rewritable, then we want to use D3D11 CPU. Oh, of course. CPU access flag right. Otherwise, you want to use D3D11 CPU access read. We're saying misc flags. We can set that to 0. A structure byte data. We can set that to 0. Okay. Now you want to set up Vertex data. Vertex data, the pieces by pieces mem. You can set that to the vertices. Vertex data, the system pitch. You can set that to 0. System slice pitch, you can set that to 0 as well. Now we want to create vertex buffer, and here we can use the result equals device create buffer, and the vertex description, vertex data, and vertex buffer. And like always, we're gonna check for it to see if we created the buffer correctly and if it didn't return false. Make sure to do that. Now finally you want to set up the index stuff. Set up index buffer description. This one's not that bad. Index buffer description. And set the usage to you can set the usage to be D3, D11. Usage default. Index buffer byte width. Size of unsigned long times the index count. Bind flags. You can set the D3, D11. Bind index buffer. CPU access flags. You want to use the read one. D3D. What's the name of it again? D3, yeah, CPU access read. I'll just copy that. I'm too lazy. This is a miss flags equals 0. And then structure byte width. You can set that to 0 as well. Now we want to set up index data. Index data. The P system equals M. Oh, no, it's not M. It's indices. Index data dot system pitch, set that to 0, and index data, the last one, sysman slice pitch, set that to 0 as well. Now we're going to create the index buffer. A result equals device create buffer. You're going to pass in the index buffer description, index data, and the index buffer. And like always, if failed, result, return false. And then towards the end, we want to make sure release memory that we don't need. Delete indices equals 0. And before we end the function, make sure shader equals shader. And return true. Or to make it more readable, actually, because it's weird that's all the way down here. And just move that to the top, actually. It's up to you. You either could have it there or on the bottom. Alrighty? Alrighty. Now we're gonna go to the render. You can have an unsigned int stride. Not strewed, stride. We can have unsigned int offset stride. You can set that to the size of vertex type, and offset it's gonna set to be 0. I believe the stride is the one that determines how much it will move to go to the next index. So to the next vertices when you pass it into actually to DirectX. Then when you say after offset 0, you want to set m shader. You can pass in begin. You can pass device context and m index count. You can call device context IA set vertex buffers. Pass 0, 1, and vertex buffer. I'm gonna pass into stride and the offsets. Gonna call device context IA set index buffers. Pass in an index buffer. The second parameter be DXGI format underscore R32 uint, and last parameter will be 0. And then we want to set device context IA set primitive topology. You can use D3D11 primitive topology, and we can make this a triangle list. Now for the last couple of vertices, last couple of functions, you can return m vertices, which I probably should have done this off screen anyway. Whatever. Index buffer and return m index count. Why? There's a pointer. Why does it? Ah. There we go. Okay. Alrighty. So build it. Make sure it doesn't create any errors, and if it doesn't, this class is done. I hope I'm gonna end it here. I don't want to make this class too much. So I hope you guys like this video. Like I said, we're not gonna render the stuff just yet. I wish I can. Maybe in the next the next tutorial. Yeah, because we have to create a texture. So in the next tutorial, we'll create a texture, and from there, before I end the video, we can render something to the screen, so at least we can see something for now. So far, we haven't shown you anything at the moment. Hope you guys are not mad about that. But anyway, but yeah, hope you guys liked this video. Thumbs up if you guys liked it, got something out of it. Tell other people about this, and most of all, I hope you guys got something out of it. You know, that's basically the point of this videos. So yeah, is there anything else I want to say? Don't think so. So next tutorial, it'll be creating a texture. So I'll see you guys then. I'll see you guys next time. Signing out. Peace.